The question is for 4-input NAND gate, what should be the transistor size? For NMOS transistor and PMOS transistor, hopefully the 3 speed 0 to 1 or to 0 to 1% speed, while we keep the chip area the smallest one, the minimum chip area. So what is your answer? What about the circuit structure? 4-input NAND gate. That's going to be 4 NMOS series. And also PMOS transistor parallel. Okay? So what's the size for NMOS and PMOS respectively? Any answer? You答案 Yes?
I'm not sure.
That's okay, try.
128 by 2.
Just a minute.
16 by 2.
For NMOS transistor,
16 by 2.
16
Yeah.
over 2, alright. PMOS transistor,
128 by 2.
I'm sorry,
128.
128
Yeah.
over 2?
Yeah.
Okay. Any other answer? 有没有其他答案
PMOS 一个 unit
PMOS 1 unit, so that's 4 over 2.
NMOS 两个 unit
Doing 8 over 2. Okay. Any other answer? 还有别的答案 So how do you derive the answer? Okay, let's try. Let's say if there's a parallel connection, we only consider one MOS, right? So we are comparing 1 PMOS and 4 NMOS. Alright. And so what's the starting point? Well, in the beginning, we say that for N, 1P and 1N, it should be 4 over 2, 8 over 2, right? That's the basic inverter. Apply that to this 4-input NAND gate, just temporarily, we just assume that 8 over 2, the same. The NMOS should be 1. Connection is serial. You have to make it what? 4 times wider to compensate, right? So that's going to be 32 over 2. However, 8 over 2 is not the minimum PMOS. 32 over 2, of course, not minimum size. So we can plug in the proportion is going to be 4 over 2. And that becomes 16 over 2. 16 over 2, 16 over 2, and 16 over 2.
NMOS
I'm sorry.
老师，
16
对啊，NMOS 原本应该16吧？
4乘4
不是4吗？
没错啊，16啊，16 over 2。
原本是16
为什么我原本是32？
啊？
为什么原本是32？
原本怎样？
为什么是32？
32。I'm sorry, let me check. OK， 就是说你今天一个 P 一个 N 的话 ，1 PMOS and 1 NMOS， 8 over 2, 4 over 2, that's the minimum, right? Try to make it 4 PMOS, NMOS connection in series. 4个 4 NMOS transistor in series. So keeping 8 over 2 the same, you should be 4 times. I'm sorry.
4倍。
写错了。
对。
It should be 16. 然后 V 是16，4倍的宽度，原本 MOS 的4倍宽度，对不对？And then because A auto is not a minimum MOS, and of course since A auto is not minimum, then we can try to shrink in proportion. So you're going to be over 200 meters. So this is the correct answer. Right?
No, no,
To make the switch speed value due to 1120. Also keeping the chip area the minimum. And you can imagine that for the other example, like F equals A, B, or C, something like that. Then what? What is the transfer side for that gate? Okay, let's continue. Spend a lot of time here. Basically, for CMOS gate, the basic structure is look like this. There's a PMOS network. We call that pull-up network. We pull the output up to signal 1. MOS network. We call that pull-down network, pulling the output to ground, to 0 volt. And these two are dual to each other. They are complementary. We call this kind of circuit design style static CMOS. And so look at this combination. When pull up off, here, when pull up off and pull down off, you get 0 off at the output, right? You get 0 here, disconnected. And when pull up on, pull up on, put down off, you get output 1, right? These two cases are the most common. Okay? But sometimes, in some special circuit, you might get pull up off and pull down off, both. When both are off, then what happens? When pull down network off, pull up network also off. It means that the output, what the voltage? 请问输出是什么样的电位？Signal 1 or 0 or what? We call that Z. We call that floating state. Floating state. Floating state. Meaning there's no connection to any power supply, any voltage. 它并没有任何的电压、电位。It's not 0. Disconnected or floating doesn't mean that it's 0 volt. No. It's all, nothing at all. It's just like you have a wire, not connecting anything. There's no voltage. 它是没有电位的。Only when you connect that to ground, it's 0 volt. Connect to power supply immediately, you get high voltage. But when both networks are off, cut off, there's no voltage at all. We call that G. G is floating or high impedance. High impedance just like insulator connecting to that point. The other one, when both are on, then what happens? Okay, floating is not very common, but indeed, in some special circuit, we might make both are on. Yes, it's still possible. But for both are on, then what happens? What will you get the output? Here we say that cross bar. It means that don't make that happen. it should not be the normal case. Because you connect to VDD, you connect to ground. The VDD and ground are competing with each other. There's a signal conflict. Eventually, we are not sure what we are going to get the output. Maybe some voltage in between. But in between, we don't know, 0, 1. It's uncertain, right? Don't make that happen for your circuit design. It should not be allowed. Okay? But you can imagine that, let's say, if this is a PMOS and NMOS, we know that this is an inverter, right? How about 4/2 and 4/2? You can imagine that the output actually is going to be a little bit more close to 0 volt because NMOS transistor, the same size, can give you higher mobility. In this case, it will, in some sense, more conductive to the ground. So this output voltage is going to be below the middle value. It's more oriented toward the 0 signal, right? But anyway, you should not make that happen. Okay? If you have that case, it's a wrong circuit design. Any question? So in summary, we know that the PMOS transistor and NMOS transistor are just like switch, on-off switch. When gate terminal input is 1, NMOS is on. PMOS transistor input 0 is on. Otherwise, they are off. And for serial connection, both must be on. For parallel connection, either can be on, it's going to be on. So that's a different combination, okay? NMOS in serial, NMOS 4 cases, 0, 0, 0, 1, 1, 0, 1, 1. Only 1, 1 is on. Okay, I'm not going to go through the other cases. You can just do over by yourself. Okay, NMOS transistor, PMOS transistor, in serial and parallel. So this kind of structure, NMOS transistor connection, the product network. These two are dual or complement to each other. For the equilibrium gate, when NMOS in serial, PMOS transistor must be in parallel. When NMOS transistor connection is parallel, then PMOS transistor in correspondence has to be in serial. That's the rule of conduction complement. Product network is complement of product network. So one in parallel, the other one must be in serial. One in serial, the other one must be in parallel. So you can imagine that if given the Boolean function like this, f equals a and b or c. But can you tell me what is the circuit? What is the circuit figure, that connection? Please draw a circuit based on the transistor for this Boolean function. What should that be? Okay, let's start from product network NMOS transistor because it's a Boolean equation, Boolean function, a and b or c. Bar means that if this is true, you get 0. When these transistor networks are on, you connect to ground. That's the product network, right? So A and B are end together, meaning they should be what? In serial. A and B. The other one, C, all together means that it should be in parallel. That's for product network, for A network. For P network, as I said, they are complement of each other. A and B has to be in parallel connection. and C should be in serial. Look like this. When AB here is in serial, then in P network should be in parallel. Connection to C in parallel, then it has to be in serial. Just complement to each other. And why? Why is that? Let's say, looking at this Boolean function, A and B, meaning if both are 1, then it's 1, right? The this logic, both A and B are 1, then A is B, A and B is 1. Or C, meaning either A, B, both are 1, or they are 0, but C is 1, then the whole thing is going to be 1. So it's just like this. When A and B is 1, then it's connected, it's on, right? Otherwise, C is 1, you also get 1. You also get on for the A network. Then you get 0 volt in the output bar 0, right? This equation equivalent to this connection. Let me repeat it. A and B is A, meaning connection in serial. Or C, this all connection, meaning their connection is parallel. Right? And why AB in serial? In parallel network, they are in parallel. Because this. Did you learn before? Did you learn the De Morgan's law? In this logic, A dot AO. I'm sorry. Have you learned this before? In Boolean function, 它叫迪摩根定律，有没有学过 De Morgan's law? You try to distribute the bar into each term. A becomes A bar, B becomes B bar, C becomes B bar, C bar, but N becomes O becomes N. So what does it mean? It means that the PMOS transistor, input is 0, this bubble here. If input 0, it's on, right? When A is 0, A bar becomes 1. When this PMOS transistor is on, VDD will connect to output. You get 1 because of PMOS transistor, A bar. They are corresponding to each other. So when A, B here connecting is parallel, so it's all. Either one is on, you get on for the network. Dot N, so it's in serial. It has to be both are 1, you get 1. You have to have 2 on, you get on for the P network. So that's why in CMOS gate, put-up network and put-up network, they are complement of each other. Just like in Boolean function, apply the Morgan's law on the equation, you get the kind of equation. Okay, any question? Ready? So that's it. This is kind of compound gate, not basic logic gate, like AND gate, OR gate, NAND gate, NOR gate inverter, but they have different combination about the AND and OR. A and B, C and D, then we put them together and then bar. So let's try to divide. First of all, as I said, try to divide based on that to come up with the product network, the AND network. AB, 2 MOS transistor, A and B, in series, right? N is N, I'm sorry. With a cannot display, but it's actually dot, meaning N together. And B, so in series. This C and D, so in series. These two are all together, so parallel connection, right? That's for N network. For P network, when I say complement to each other, when A and B in series, then PMOS transistors are parallel. CND in parallel. These two here in parallel, then AB and CD in series. These two are in series. Can you see that? 这两个像是串联的。These two are in series. Then you come up with this network, this circuit. And that's a common gate. ABN, CDN, and then all and invert. That's how you design your compound gate for your circuit for the Boolean function. How about it? A or B or C, and the whole thing, and D in bar. We call that all three AI. What do I mean? There are three input or gate. A no number meaning two input, by default two input. So two input and gate. And then invert. That's a bar. Meaning ABC or A, two input, then invert. Equivalent. But that two different gates. One three input OR gate, two input NAND gate. These are two separate gates. And these are two stages. They can be implemented in one stage. That's compound gate. The whole thing is a gate. Okay? And that's the circuit. First of all, starting from a network. ABC all together, so ABC in parallel. And it's D, so connection with D in series. And complement in a P network. ABC in parallel, then here should be in series. With D in series, then with D in parallel. That's the circuit for this Boolean function. There's only one stage, one compound gate. And by the way, when we design compound gate, the input here, there are three inputs. And typically, you should not have too many inputs. Three, maybe at most four, should be fine. But over that, more input than that is going to be a very bad design for the compound gate because the circuit speed, when you connect several transistors, and if the number of the serial connection is more than 3, or maybe more than 4, that's going to be very slow. The more input, the slower the circuit, and the delay increase is larger and larger and larger. Meaning, even like 6 input or 8 input compound gate is going to be very, very, very slow. It's a bad design. Even that case, for example, if you have want to design an OR gate, okay, let me say OR gate, and there are 6 input. Don't design that gate using this kind of design. 6 input, maybe 6 input gate. Don't design that in one gate. 6 input in series in a product network, and 6 PMOS transistor in parallel in product network. Don't design that way. You should decompose into 2 stages, meaning you should be looking like this. And then what? And then what? Then it should be all. something like that. Is that right? Are these two equivalent? Or you can check. If output A and B and C, D, E, F, bar, right? There's a corresponding Boolean function. How about this? A, B, C, bar, or D, E, F, bar. Are these two equal to each other? True or false? True. Democracy law. Remember that? If this is term, it's another term. We apply bar distribute to each one. So ABC bar, A dot become all. A become all. And D another term, just bar. Yes, these two are equivalent. And okay, so we know how to implement 3 input NAND gate, and these are good circuit. Only 3 input, fine. 6 input is bad because it's going to be very, very slow. Not just that 2 times delay or 3 times, it's more than 2 times, 3 times delay, even more. The delay goes up drastically. But again, how to implement OR gate? How to implement A or B? There's no bar here. Then how to implement using steady state mode? What's the circuit here? What is the circuit for product network? What is the circuit for product network? 要怎么设计它的CMOS逻辑答案？用 transistor 怎么设计？因为那是没有 bar，there's no bar there. Then what to do? Fine. You simply do this way. So that's a 2 input NOR gate, and then inverter. Because steady state mode is a negative logic. 它是一个负逻辑。You always get bar on the equation. Because we have product network in the bottom, product network in the top. It has to be a bar in the equation. But if you want to have positive logic, fine. Just give an inverter at the end. That's going to give you a 2 input OR gate. So you should know that AND gate and NAND gate is 2. Which one is simpler? Which one is a smaller chip area? It's got to be 2 input NAND gate. 2 input NAND gate is simpler than 2 input AND gate. Because you simply implement that using steady state mode. But for this 2 input AND gate, it's got to be 2 input NAND gate connected, cascaded with the inverter. It's more complex, it's more circuit, it's more chip area in comparison. Okay, go on. Talking about signal strength. Typically, we only consider 0 and 1 for signal. Because we are talking about digital logic, only value 0 and 1. Maybe floating, no signal at all. But in reality, in a circuit theory, in a circuit reality, there is some kind of some sense of signal strength. When you talk about signal strength, it means that how close is approximate ideal voltage source. For example, for inverter, okay. For the inverter, something like that. For this inverter, the output here, this point, that's the output. What do I mean by signal strength? When MOS is on, PMOS is off, you got 0, right? On the other hand, when M is off, PMOS is on, you get 1. However, 0 and 1 just the logic value. In reality, that corresponds to some voltage, okay, voltage level. Signal strength indicates that how strong the signal is, meaning how it's close to your ideal voltage. When you get 0, when MOS is on, actually it's not really ideally 0, no. You still have some voltage. 它是还是有点点电位高一点. It's going to be a little bit higher than 0, but it's very close to 0. We know that it's still 0, not 1. When PMOS is on, MOS is off, it's going to be getting 1. This 1 means that if this VDD is like 2 volt, then it's going to be close to 2 volt, but not really ideally 2 volt. But simply very, very close to 2 volt. And how close is it indicate how strong the signal is. 它的多接近高电位2.5伏特，例如它是2伏特的话，或低于多接近它0伏特，代表它讯号的强度。For example, if it is 2 volt, it is 0 volt. The output is something like 0.8 volt, maybe 0.7 volt. Typically, we can recognize that, okay, it's closer to 0 volt, it's more far away from 2 volt. We will recognize that it's 0 volt, signal 0. But it's not a strong signal, it's a very, very weak signal. 它不够接近0伏特，它是一个比较弱的0伏特，它是一个比较弱的零的讯号。When the output is something like 1.3 volt, we recognize that as signal 1, but it's a weak one. 它是一个弱的讯号 because it's not really close to 2 volt. Although it's even farther away from 0 volt, so we know that to signal 1, but it's a weak one. It's not very, very close to just 2 volt, no. 它实际上离2伏特还是有点距离，它不是很强的讯号，是一个弱的1的讯号。So that's what we say signal strength. How close it approximates ideal voltage source. VDD and ground, rail 这两个轨道 they go through the whole trip, providing VDD and ground to each circuit. Each gate are strongest 1 and 0. VDD and ground 就是最强的1跟0的讯号 the strongest one. No other signal can be stronger than these two. And MOS transistor has strong 0. MOS transistor 呢是可以传递强的0的讯号。When this is a MOS transistor, and this is a 0 volt. And it's on. When it's on, you're getting signal 0, right? You're getting 0 volt. And it can pack strong 0. Not really 0 volt, but it's a strong signal. But degraded or weak 1. However, for MO transistor, it's on. Okay, strong 0. When it's on 1, it's going to be weak 1. 它是一个比较弱的一个讯号 ，meaning it's not really the VDD voltage, a little bit lower than that. 它是一个比较弱的一个讯号。So MO transistor tag or produce weak or degraded signal 1. On the other hand, PMOS transistor has strong 1. A very good 1. Not really the most high voltage, but close, very close. Okay, so strong 1. However, to connect 0 signal, this weak 0 meaning you are not getting 0 volt, but a little bit higher than 0 volt. So that's a weak 0 signal. So that's why we use NMOS in the product network. We use PMOS in the product network. Why? Because a network connecting to ground, right? Look at here. We use NMOS in product network. We use PMOS in product network. That's the reason why. Because NMOS transistor had good 0. PMOS transistor had good 1 to the output. If we do that again, product network, use NMOS, product network use PMOS, that is going to be very bad. You're getting weak 0. You're getting weak 1. Alright? Because PMOS transistor is good at pack strong 1, but weak 0. MOS transistor is good at pack strong 0, but weak 1. So this is not the right way. This is not the correct design. So that's why MOS transistor 是传递强的，这个可以传递强的一个零的讯号。PMOS transistor 可以传递强的1的讯号，各司其职，各有它的优点，所以它这样分配，这边一定要用 MOS， 这边要 PMOS， 才会给你一个够，有给你 good strong 1 or strong 0 either 0 or 1 in the output. But even weak 1 or weak 0, you can still recognize it's a 0, it's a 1, yes. 你还是可以认得出来，它是一个1跟0，只是它是一个弱跟一个弱的1跟弱的0。So what are the disadvantage of weak 1 or weak 0? Is there any disadvantage? The answer is yes, it's a disadvantage. If it's a gate output, and it's going to connect to more than one gate, something like that. Anyway, if this gate output connected to 3 different gate input, we call fan out extreme. fan out. Three. Okay, there are three connections toward three different gate input. Fan out is three. And as I said before, there is always resistance and capacitance in the transistor. 你永远有电阻是电容子在resistor 输出端 ，and the output, this output connect to three different input. The more input, you have higher capacitance, higher resistance， 你有更高的电阻电容。那 your signal strength， 这叫讯号的推，能够推到多少 output？The output is going to be used to drive a few number of gain, few number of gain input. We call that fan out stream. The more fan out, the higher fan out, your loading is higher. 它负载越强，你的 resistance and capacitance is higher. Your loading is higher, meaning you need stronger signal to drive high loading. Otherwise, you might get low signal level, not high enough for 1, not low enough for 0, something like that. So each gate is a limited number of fan out. 每一个逻辑塔都有它能够推动的最高上限的一个输出数量。The fan out is limited. If this one creating like maybe 100, then it's going to be something wrong. You are not getting the correct signal level because too higher fan out, too much loading in the output. The driving capability of the signal strength is not enough. 你的讯号的强度不够，推动那么高的一个节点，下一个 stage 的节点。That relates to the signal strength. Oh, okay. I probably have to stop. Although we did not advance too much in terms of the data style, but it's okay. At least we try to explain in details the basic circuit theory and why the behavior for different circuit structure. 至少我们把一些比较基本的电路的原理跟大家解释清楚，这样比较容易了解它逻辑闸的一个运作，它的细节怎么运行。Any question? Alright, as I say, 2 weeks from now, there's going to be a quiz in the first hour, so please don't delay. Be on time. Yes? Question? Okay, that's it for today. I'm going to send this actual drawing or writing and provide that in the system for the revised version of the slide. 我会把它上传，那保留那些手写的字迹作为这个更新版，我们2周留在那边。